Hi biology students. I wanted to do a quick tutorial for how to run the disease simulation activity. For this particular simulation, we're going to be looking at the way that certain pathogens affect different populations based on the number of people, the population itself, who is susceptible, who might be immune, as well as actually how transmittable or communicable the disease is. To do that, we're going to go to this outside website, the Habitable Planet, and it looks like this. And you'll also, you're going to need a data table. And the data table actually, if you look, the data table takes you through a couple of different lessons. So lesson 1, there's actually 2 steps. And lesson 2, there are 2 steps. And lesson 3, there are also 2 steps with questions here at the bottom. Okay, back to the simulation. Over here is the overview. The overview is going to tell you a little bit about how certain diseases caused by viruses in particular or bacteria affect human and animal populations and how they're spread. What we really want to look at are the simulations. So after you read through here, it talks about the data table. You can also download the data table here if you can't find it on Schoology. Let's go to step 1. In step 1, it's going to have you look at a cold with a K, and how it affects a certain population over a period of 100 days. And we're going to look at it 3 different times. So open the simulator, and when you open the simulator, it's going to look like this. So here's day 1. So we haven't quite started yet. Oh, but there's a contagious person, and there's a contagious person. And right now, nobody's taking any sick days. We're starting off, no one's died, yay. But we're going to run this simulation, okay? Over here, it's going to give you a little bit of graphic detail. So if you don't want to look at the pretty dots here, you can look at the actual numbers over here as we run our disease through a population. Don't worry, this isn't too virulent of a disease. It's just a cold. On our data table, we're going to make a prediction. Where's my data table? Here we go. So I'm going to make a prediction. I don't know, population number. Well, I already know there's 600 people, but I want to know out of 600, the starting number of contagious people. Okay, well, I can already see it's 2. And there's 0 sick days. And when I'm done, what's my prediction? I don't know. Maybe half of them are going to be contagious, 3/4 of them, we're not sure. So let's run the simulation. We're going to run it 3 separate times and write our data here. We just have to make our prediction once. And let's run it. Oh, goodness. Well, the people surrounding that contagious person over here, looks like they got it. Oh, but now they're immune. Interesting. So do you see where it says? Sorry, the dot's down here. So who's at risk, who's immune? So when I'm done, population, I've still got 600 people. Total number of sick days are here. And the total number of people infected, all right, we can look. No one's died. That's good. Our immune system went up. Our at-risk system number of people went down. And this is my total number of contagious. So let's look at the details. Transmission rate was about 10%. Death rate was 0. Thankfully, no one died. People were sick and therefore contagious for about 5 days. This is a medium population density, but I can play around with the number of people if I wanted to. So going back to your data table, over here, starting number of contagious people, in that case, was it 2? Let's reset and run again. We'll do trial 2. Whoops. Okay, so 3 people this time. And at the end, I wonder how many, maybe I made a prediction that 20 would be contagious. Okay, nobody's contagious at this time. That's pretty good. And the contagion rate. Hi there, biology students. I wanted to show you a quick tutorial on the disease simulation activity because it has a lot going on. We'll start off here. And this simulation is helpful for our study of epidemiology or virology, looking at the way that diseases can move throughout a certain population. Obviously a very important field of science and a lot of different terminology that we'll look at. So a couple of things. We'll be going to an outside website to run the simulation. And we've also got the data table down here you can click. Some of you, particularly PC users, might find this top one better. Mac users, this bottom one. You can also download it from the website, which is here or here. So let's go to the website. The Habitable Planet, there's a quick overview that just talks a little bit about how disease travels within a population. And that can be animal population, plant population. Most diseases are caused by a pathogen, one of three, a virus like the common cold, bacteria, or a fungal. So we're going to be researching a couple of different things. The data table is going to help us keep track of our information. So there's three different kind of lessons, different simulations we'll be using, and there's two different steps we'll be taking for each of those. So all of your data will go on this table, and you can just upload that when you're done. For the first lesson, we're going to be looking at the way that the common cold with a K travels through a population, and we'll learn a little bit about it here. We're going to be studying disease. Epidemiology does this, looking at disease over time and using it to come up with predictions, ways to describe how the disease is transmitted or how contagious it is from one population to the next. So step one, if you click here, we're going to open up the simulation by clicking here. And in this simulation, we're going to start off by making some predictions. Right now, the cold, here's the disease, the cold that we are going to be investigating. And our population density is medium. We've got about 600 peeps, but we can change that over here if we want to give them a fewer number of peeps or a higher number of people. We'll just make sure that we change that on our data table. So the little buttons here, you can see that the people that are contagious are in red, and the people that are immune, I don't see any immunity because this is a virgin field. This is a brand new virus, so no one's had a chance to develop immunity. And I've got about 3 sick folks and a population of about 600. Starting at day 0, no one's died. Hallelujah, no one's sick. But I'm going to make predictions about how sick this disease might get people. And this cold, it lasts for about 5 days. So let's see on our data table what we can fill in. The first thing it's going to have us do is fill in our population size, and in this case just use the same population for all 3. So I would just put 600 for all 3 of these, right? And then I'm going to make predictions. Right now, I can actually see that I've got 3 people who are contagious, but I'm going to predict that sick days. I don't know, everybody's sick for like 5 days. That's like 15 people at least, or 15 days if there's 3 people. And I don't know, I'm going to predict that these people spread it to, I don't know, maybe 20 or 40 other people, right? And I'm going to predict that they're sick for, I don't know, 40 days. The contagious rate or contagion rate, I can see here, the transmission rate is 10%. So not much prediction, but I can increase that, right? I can make it much easier to spread or less easier to spread. Bella, that was my dog. Okay, so now I'm going to run the simulation. I'm actually going to run the simulation 3 times. So I do that up here. And let's see what happens to everybody. Oh no, because they're hanging out and getting their neighbors sick. Now over here, I'm going to see a few things. I'm going to see 0 people are sick afterwards, which is awesome. I don't see any red. So the actual contagious folks are done. So it's run its course over 100 days. But I'm going to also see the immunity go up. So I've got some people, the people that had it already, be immune to this, and that's going to decrease my number of at-risk people, which is kind of cool. So on here, I'm going to fill out my data table, and I've got my actual data here. It tells me how many people. There's 0 people sick right now, but let's look at the sick days. Dang, we had a lot of sick days. So 557, and per capita, that's looks like that. And then my contagion rate, right, I've already got here, whoops, over here. So transmission rate's about 10%. Now I can play with this. I can make it a cold that's much worse and apply that and then run that. So reset and then run and see what if I make this a much more contagious cold. I can also make this cold a longer period. So say you've got a really like 10 days in which time you're sick and run it that way. Right? So I can play around. Wow, dang, that was crazy. And then I'm going to use that to fill in my different information. So you can leave things the same. You can change them around. But we're going to be looking at what happens within a population and how it spreads. Lesson 2. Lesson 2, the steps are a little bit different. Instead of being here. Oh, by the way, the questions, I should go back. The questions are at the bottom here. So when you go, I can tell you a little bit more about that. Step 2, I'm going to make a prediction again. after